differential. The differential represents the principal part of a change in a function y equals to f of x with respect to changes in the independent variable. The derivative of a function can often be used to approximate certain function values. And the derivative of a function at a point x sub o written as f prime x sub o is defined as the limit as x approaches 0 of the quotient delta y over delta x, in which delta y is f of x plus delta x minus f of x sub 0. So we'll have an example. If y equals to x cubed minus x squared plus 4, find the approximate value of y when x equals to 1.03 using differential. So your solution would be y plus delta y is the approximate value. So assume x equals to 1 and dx is equals to 0.03. So for y equals to x cubed minus x squared plus 4, substitute values, we have 1 cubed minus 1 square plus 4 is 1 equivalent to 4. So for dy equals to 3x squared minus 2x times dx. So substitute values, 3 times 1 square minus 2 times 1 times 0.03. dy equivalent to 0.03. So the required approximation is y plus dy equals to 4 plus 0.03. So it's equivalent to 4.03. Right, number 2, an ellipse has a semi-major axis of 8 meters and semi-minor 6.2 meters. If these axes are increased by 0.12 meters each, find the differential increase in the area of the ellipse. So this one, area equals to pi AB. Differentiate dE all over, d equals to pi times A times dB plus pi times B times dE, equivalent to pi times 8 times 0.12 plus pi times 6.2 times 0.2 is 1 equivalent to 3.0159 plus 2.3374 equals to 5.3525 meters squared. So your dE equals to 0.12. So dB equals to 0.12. So your DE, the change, differential increase in the area of the ellipse, is equivalent to, so your DE equals to 5.35325 meters squared. Right. If the diameter of the circle is measured with a maximum error of 0.003 inches, and the area must be accurate within 0.12, find the largest diameter of the circle. So let x equals to diameter of the circle. Diameter of the circle. Dx equals to 0.003. Then dE equals to 0.12 inches squared. So your A of the circle equals to pi d square over 4 by 4 times x squared. So dE equals to pi 4 times 2x dx equals to pi 2 x dx. For 0.12 equals to pi 2 x times 0.003. Then your x equals to 2 times 0.12 all over pi times 0.003. Your x equivalent to 25.465 inches. What is the allowable error in measuring the edge of a cube intended to hold 27 cubic feet if the error in a computed volume is not to exceed 0.05 feet cube? So volume equals to x cube. Differentiate dV equals to 3x squared dx. Then 27 equals to x cube. So x equals to 3. So dV equals to 3x squared dx. 0.05 equals to 3 times 3 square dx. So your dx equivalent to 0.05 over 27, or simply 0.00185 feet. Find the approximate increase using differential in the volume of sphere if the radius increases from 0.4 to 4.04 meters. So solution, volume equals to 4/3 pi r cubed. dV equals to 4/3 pi 3r square times dr equals to, but your dr is equivalent to 4.04 minus 4, or equals to 0.04. So your dV equals to 4 pi all over 3 times 3 times 4 square times 0.04, or simply equals to 4 pi 4 square times 0.04 equivalent to 8.0429 in meter cube.